gas laws. What are gas laws? Gas laws actually are the relationship between the volume of a given mass of a gas with some certain prevailing conditions of temperature, pressure, etc. There are many gas laws presented by different scientists like Boyle's law, Charles' law, Graham's laws, and Dalton's law. We will study them one by one. So first of all, we will study Boyle's law. Okay, according to the statement of Boyle's law, the volume of a given mass of a gas at a constant temperature is inversely proportional to the pressure applied to the gas. It means that at a given the constant temperature and constant quantity of gas, the pressure of a gas will be inversely proportional to its volume. What is the meaning of inversely proportional? Inversely proportional means if one quantity is increasing, the other one will be decreased, and vice versa. So here volume and pressure are inversely proportional to each other. It means if we apply more pressure, then volume will be decreased, and if we reduce the pressure or lessen the pressure, the volume will be increased. So these are inversely proportional to each other. When we remove this sign of proportionality, then we know that for removing sign of proportionality, we have to insert some constant, and here k is the constant, and k is called proportionality constant. In order to find the value of proportionality constant k, the equation will become as k is equal to P into V. This pressure is dividing here, so it will be multiplied by with V. So K is PV. This is the mathematical form of Boyle's law. Now, if we apply this law at different or at initial pressure volume value or at final pressure volume value, then we will see that the product of pressure and volume will be a constant quantity. For example, we have a pressure, initial pressure P1 and volume V1. Similarly, we have a final pressure as P2 and a volume V2. The product of Boyle's law will always be a constant quantity, that is P1 V1 will be equal to P2 V2 is equal to K. Okay, now we will prove it experimentally that how these products of pressure and volume are constant quantity. So start. Okay, so proof experimentally Boyle's law. We have taken a cylinder with a movable piston and with the help of this piston we will apply more pressure or will reduce the pressure, and the effect of pressure will be seen on the volume. Remember that we are performing or we are experimentally proved this Boyle's law at constant temperature, and the value of temperature is constant, that is 25 degree Celsius. Now in the first case we have a pressure of 2 atmosphere and the volume is 1 decimeter cube. So P1 we can say that is 1 atmosphere because a unit of pressure is atmosphere and the volume is 2 decimeter cube. Now the product will be 1 multiplied by 2. So product value is 2 atmospheric decimeter cube. In the second case, when we apply more pressure, now the pressure will become as 4 atmosphere, and when we press this piston, the volume ultimately will be reduced or decreased. So here the value of pressure is 4 atmosphere and volume is reduced to half decimeter cube. When we multiply these P2 and V2, we will get the value of 2. Similarly, in the third case, when we apply more pressure, then the value of pressure will become 6 atm, and by applying more pressure, the volume will be decreased further. So volume will be reduced and the third volume will be 1 by 3 decimeter cube. Now the product of P3 and V3 would be 6 multiplied by 1 by 3, and product, that is K, is equal to 2. So you can see in all cases, by changing the value of pressure and volume, the value of product is constant in all cases at a constant temperature. So it was the experimental verification of Boyle's law that by even by changing the value of pressure and volume, the quantity of or the product of pressure and volume work will be a constant quantity, and it is according to the Boyle's law. Now we will prove it graphically. Okay, in our first case we are taking pressure on x-axis and volume on y-axis, and the temperature you know is constant, that is at 0 degree Celsius. Okay, we know that pressure and volume are inversely proportional to each other. So if pressure is increasing, the volume will be decreased, and if the pressure is lessened or it is decreased, the volume will be increased. So it means that at zero pressure, the volume of a gas will be higher. As we are increasing pressure, the volume will be reduced, and when the pressure is too much high, the volume will be too much decreased. So in this way we get a curved plot between pressure and volume, and this curve or this type of graph is known as isotherm. Why isotherm? Because it is plotting at constant temperature. Iso means constant and or same, and therm means heat. So because this graph is plotting at constant temperature, that's why the curve which we obtained is called as isotherm. Now if we increase the temperature from 0 degree Celsius to 25 degrees Celsius, the same curve will be appear at higher note. Here the relationship between pressure and volume is constant, but due to increased temperature, this curve will be appear at a distant value. Okay, if we now plot a graph between pressure and 1 over volume. Okay, wait a minute. Yes, we are taking now pressure at y-axis and 1 over volume at x-axis. Now remember that in the first case we were taking only the volume, but here we are taking 1 over volume. Pressure and volume were inversely proportional to each other, but pressure and 1 over volume or inverse of volume are directly proportional to each other. So it means as the pressure is increasing, volume will also 1 over volume will also be increased. So we will get a straight line between pressure and 1 over volume. Okay, this was the second case. Now if we talk about third case, is in which we are taking pressure at x-axis and the product PV or constant K at y-axis, then what will be happened? Okay, here we are taking pressure at x-axis and product of pressure and volume, that is K, on y-axis. Now you know that PV is a constant quantity. So it means by increasing pressure or volume, the product will be constant. So we will have a constant value of pressure and volume at any pressure, because the product is always a constant quantity when temperature is constant, and by varying the value of pressure and volume, the value of product PV or constant K will be a constant quantity. So we will have like this a constant quantity graph. So this was all about Boyle's law. In the next lecture we will study about the Charles law. Thank you for watching my videos. If you like and want to understand more, you can tell me in the comment section. Like my video and subscribe my channel. Thank you.